In this video, I'm going to go through the solutions to the test in Unit 3. The first question was, which of the following statement is not true in describing the graph of an exponential function of the form y equal a exponent x if a is greater than 0? Between the options, the first option says the graph passes through the origin. We know that origin x equal to 0, a exponent 0 becomes 1, so y is 1. So it means that it doesn't go through the origin, because if it goes through the origin, y has to be 0. So a is true. The range is set of positive real numbers, which is incorrect, because if you remember, if you plot this graph, you're going to get something like this one, and line y equal to 0, which is the x-axis, is going to be the horizontal asymptote. So the negative values for y are not defined, so this option is not correct. The next one, the same as a, it says the graph passes through the origin, so the answer is correct. And the last one, y increases as x increases when a is greater than 1, which is also true. So this option also is not valid. So any one of A or C is the correct answer. The second question says, which of the following function always decreases as x increases? The first one is y is equal to 0.1 exponent x, since 0.5 is less than 1 and greater than 0. This is going to be an exponential decay, which looks like this graph, and it shows you that as x increases, y decreases. So this is correct. This one is incorrect. The next one, which is B, because C is greater than 1, so it's going to be exponential growth. This is also is incorrect, because 3 is greater than 1. And this one, because negative 3, the absolute value is negative 3, is going to be 3, and it's going to be greater than 3. This is not going to be an exponential decay. So as x increases, y is going to decrease. Remember that negative 3 is going to be just a reflection about the y-axis. That's all it does. So the answer to question 2 is A. The next one says the graph of y equal to c a exponent x plus t is related to the graph of y equal a exponent x by, looking at this one, it says a vertical stretch by a factor of c, which is correct because of c here, and a vertical shift by d units, which is correct, d units. So this is correct. Question number 4 says the equation of an exponential function y equals c times a exponent x models exponential decay. As we learned before, that when a is between 1 and 0, this is going to be an exponential decay, so the correct answer is D. And the last one, you have a fruit fly with an initial population of 20 quadruples, meaning that it multiplies by 4 every hour. Which equation models this exponential growth? This is not correct, because it says the initial value is 4. This is correct. It says the initial is 20, but but this one says that every hour is going to be 5-fold, which is incorrect because it quadruples. This one initial is 20, and every hour it increases by 4-fold. So this is the correct answer. And this one is incorrect, because this one tells you that it's going to be 1/4 every hour. The next question, we have to evaluate the following and leave the answers as exact. The first one is -4 exponent -2. I can write this one as -1/4 exponent 2, which is -1/16. The next one is 64 exponent 4/3. I can write 64 as 2 exponent 6, which is 64 exponent 4/3. Since we have power to a power, we're going to multiply the exponent. I get 2 exponent 6 times 4 is 24 divided by 3, which is 2 exponent 24 divided by 3 is 8. This is going to simplify to 256. The next one is -√6 of 9 exponent 3. I'm going to write this one as -9 exponent 3√6. I can write it as a fraction like this one, but 9 is the same as 3 exponent 2 exponent 3/6. Since you have power to a power, I'm going to multiply exponents, so I'm going to get 3 exponent 2 times 3 is 6/6, which is going to be -3 exponent 1, which is -3. The next question is 9 exponent 3/2 minus 1/8 exponent -2/3 plus 2 times 5 exponent 0. The first thing is that 5 exponent 0, any number exponent 0 gives you 1. So this is 1. So 2 times 1 gives you 2. Now 9 exponent 3, I can write it as 3 exponent 2 exponent 3/2 minus 8. I can write it as 8 exponent -1 and -2/3 plus 2 times 1 gives me 2. Now, power to a power, so I'm going to get 3 exponent 2 times 3/2 is 6/2 minus, again power to a power, I have 8 exponent -1 exponent -2/3. Negative times negative gives me positive, so I get 2/3, but 8 exponent 2/3 plus 2. 3 exponent 6/2 is the same as 3, so you get 3 exponent 3 minus 8 can be written as 2 exponent 3 exponent 2/3 plus 2. 3 exponent 3 is going to give me 27. 2 exponent 3 exponent 2/3 is the same as 2 exponent 6/3 plus 2. 27 plus 2 gives you 29 minus 6/3 gives you 2, so 2 exponent 2, which is 29 minus 4, which is going to give us 25. The next one, we are supposed to write the following exponential form using positive exponents. So the first one, I can write as u exponent 1/2 times v exponent -3, the whole thing exponent -2. I'm going to distribute -2 inside the bracket. I'm going to get the u exponent 1/2 exponent -2 times v exponent -3 exponent -2. Since I have power to a power, I'm going to multiply exponents, so -2 times 1/2 gives me -1, and -3 times -2 gives me 6. Since I have to express it as a positive exponent, I can write this one as v exponent 6/u. The next one is 2m³ n² exponent -2 divided by 2m exponent 4 n exponent -1, the whole thing exponent -3. First, I'm going to distribute -2 inside the bracket with every term, and the same with -3. So I'm going to get 3 exponent negative 2, m exponent 3 exponent negative 2, you multiply, so you get negative 6, n exponent 2 times negative 2 gives you negative 4, divided by 2 exponent negative 3, m exponent 4 times negative 3 is negative 12, n exponent positive 3. Now, since we are dividing, this means that I have to flip the second fraction and then multiply. So I'm going to get 3 exponent negative 2, m exponent negative 6, n exponent negative 4 times 1 over 2 exponent negative 3, m exponent negative 12, n exponent 3. Now, I can write this one as 3 exponent negative 2, m exponent negative 6, n exponent negative 4 over 2 exponent negative 3, m exponent negative 12, n exponent 3. Now, this is the same as 3 exponent negative 2 over 2 exponent negative 3. Now, since you are dividing and they are the same base, you are going to subtract. So m is going to be exponent negative 2 minus 12 is going to be 12 minus 6, which is 6. Negative 4 minus 3 is going to give us n exponent negative 7. Now, since we have to express everything as positive exponents, I have 3 exponent negative 2, so I will put it in the denominator to become 3 exponent 2. 2 exponent negative 3 in the denominator. To make it positive, I'm going to put it in the numerator, so it becomes 2 exponent 3, m exponent 6, and n exponent negative 7, I'm going to write it in the denominator to make it positive. So this becomes 2 exponent 3 becomes 8, m exponent 6 divided by 3 exponent 2 is 9, n exponent 7. The next question is to solve for x. The first one is 3 exponent 3x plus 1 is 9 exponent x minus 1. Instead of using log, since 3 and 9, I can represent 9 in terms of base 3. I can write this one as 3 exponent 3x plus 1 is 3 exponent 2, which is 9, exponent x minus 1. So I can write 3 exponent 3x plus 1 is 3 exponent. Because I have power to power, I can multiply exponents. Now, since the bases are the same, we know that the exponents, they have to be the same. So 3x plus 1 is 2 times x minus 1, which is 2x minus 2. Now I'm going to isolate x by moving 2x to the left and 1 to the right. So I'm going to get 3x minus 2x is negative 2 minus 1. So 3x minus 2x is x is equal to negative 2 minus 1 is negative 3. Remember, you could solve this one using log 2 and you would get exactly the same answer. The next equation is 3 exponent x minus 2 is equal to 76. Since I cannot represent 76 as a power with base 3, I have to use log function. So I take the log of both sides. I get x minus 2 times log 3 is equal to log 76. So dividing by log 3, canceling log 3 here, I am going to get x minus 2 is log 76 divided by log 3. Moving negative 2 to the right, I get x is 2 plus log 76 divided by log 3. If you simplify this one, you get about 5.94. The next question is, we have a function y equal 3 times 2 exponent x plus 4. We are supposed to find the following. 1. The horizontal asymptote. We know that the horizontal asymptote is a constant here, so we say the horizontal asymptote is y is equal to 4. So this means that the horizontal asymptote is going to be a line like this one. Now the y-intercept. By definition, the y-intercept is going to be the one where x is equal to 0. So the y-intercept is 3 times 2 exponent 0 plus 4. 2 exponent 0 is 1, so 3 plus 4, which is going to be 7. So the y-intercept is going to be a point here. Now, is the function increasing or decreasing? Before I do that one, I'm going to plot the function and then decide what exactly is happening with the function. When x goes to negative infinity, we can see that the function becomes 3 times 2 exponent negative infinity plus 4. We know that any number where the base is greater than 1 and the exponent goes to a very, very small number, this becomes almost 0. So 3 times 0 becomes 0, and this means that the function goes to about y equal to 4, which is somewhere around here when x goes to infinity. When x goes to positive infinity, the function becomes 3 times 2 exponent positive infinity plus 4. Since again the base is greater than 1, any number exponent very, very large number becomes very large number, something like infinity. So this term becomes almost infinity. Infinity plus 4 is again infinity, so we're going to get somewhere around here. So our function is going to look something like this one. Now, if we walk along the graph from left to right this way, you can see as we walk along the graph, as x increases, y also goes up. So y is increasing. So this means the function is increasing. The next part of the question asks, what is the domain? From the graph, remember the graph looked like this. You can see that there is no restriction on x, so we can say that the domain is x in R. For the range, we can see that any y value which is greater than y equal to 4 is the answer. So the range is y in R and y greater than 4. The sketch of the graph. To sketch the graph, we are going to find the mapping notation. So to find the mapping notation, we are going to write the function again. Remember, the function was y is equal to 3 times 2 exponent x plus 4. So from this function, I know that a is 3. Since the coefficient of x is 1, b is 1. Since there is no constant added or subtracted from x, so h is 0 and k is 4. So we can write that the mapping notation is xy become 1 over b, which is 1 over 1 x, plus h, which is 0, ay, which is 3y, plus k, which is the same as 1 over 1 is 1, so x plus 0 is x, and 3y plus 4. Now I'm going to use the mapping notation, and I'm going to try to find the table of values for the transform function. Remember, the base function here is y is equal to 2 exponent x. So our base table of value xy, assuming we go with x0, 1, 2, 3, becomes When x is 0, we are looking at this function. When x is 0, 2 exponent 0 is 1. When x is 1, it becomes 2 exponent 1, which is 2. When x is 2, 2 exponent 2 is 4. When x is 3, 2 exponent 3 is 8. Now I'm going to apply this mapping notation to this table of values to get the table of value of transform function. We can see that the mapping notation x doesn't change, so all these are going to stay the same. So we're going to get 0, 1, 2, 3. But the y value of the base function are going to change based on this expression. So when y is 1, 3 times 1 is 3 plus 4 is going to give me 7. When y is 2, 3 times 2 is 6 plus 4 is 10. When y is 4, 3 times 4 is 12 plus 4 is 16. And last, when y is 8, 3 times 8 is 24 plus 4 is 28. And using this one, I can plot the points and I can get a function, a graph like the following. And the last part of the question asks us to find the mapping notation, and we found it before that the mapping notation is x, y gives to x and 3y plus 4. And we are not going to redo it again. The next question is a communication problem. It says describe a scenario that would result in each of the following exponential equation. For instance, an exponential equation like this one. You can see that the initial value is 20, and this is exponential growth, and it's increasing threefold every unit of time. So we can say that we start with 20 viruses and they triple every hour. That's one way of saying it. So the answer can be infinite number of solutions. The next one is this equation. The initial value is 5,000, and this time we are decreasing. So we can say that the initial value of a second-hand car is $5,000, and the value of the car decreases by 25% every year. Now the reason we said 25% is that you subtract this base because it's less than 1 from 1, you get 0.25, then you multiply 0.25 by 100%, you get 25%. So initial value is $5,000 and the price of the car decreases by 25% every unit of time. The next question says that you have a bacterial culture which grows exponentially. The initial population is 1,000 and the population grows to 7,000 after 1 hour. The question is that what is the equation of the population after 3 hours? Since we grow to 7,000, meaning that it is sevenfold in 1 hour, I can write that P is equal to 1,000, the initial value, times, because it's sevenfold, and because it happens every 1 hour, so I'm going to say X or T. So this is my equation now. During which hour will the population be 300 million? I'm just going to substitute 300 million in the equation, and then I'm going to try to solve it. Now the 3 zeros are going to cancel with 3 zeros. To solve this one, I'm going to use log function, so I get t log 7 is log 300,000. So t is approximately log 300,000 divided by log 7, which is approximately 6.48 hours. The next question says you have a radioactive element which has a half-life of 4 seconds. You begin with 60 grams of that material. We are supposed to write the equation. We know that we are talking about half-life, so the base of the exponential is 1 over 2. So we're going to say that y is, the initial value is 60 times 1 over 2. But since it happens every 4 seconds, so we're going to have t over 4. Now you're supposed to find how much is remaining after 36 seconds. So we are going to say y is 60, 1 over 2, 36 over 4, which is 60 times 1 over 2 exponent 9. If you use your calculator, you get 0.117 gram of radioactive material left. The next question says, what percent of the original mass is left after 20 seconds? The way we do it is that, let's say that p% is left. This means that the amount left is 60 p. P is the percent, remember. And the equation is 60 times 1 over 2 t over 4. Remember, p is the percentage which is remained. But t, it says after 20. So this is really 60 times 1 over 2, 20 over 4, which is equal to 5. Now, if we solve this one for p, I'm going to divide by 60. So I'm going to divide this guy by 60. 60 goes with 60. So p is really 1 over 2 exponent 5. If you evaluate 1 over 2 exponent 5 and then change it to percent, you're going to get p is 0.03, which is equal to 3%. So 3% of the material is left after 20 seconds. In the next question, you have a printing company which has a photocopy machine for $250,000 in year 2005. The machine's value depreciates, meaning that it goes down 25% per year. The question is, how do you write an exponential equation describing the value of the machine after t years? Okay, we write that y is equal to initial value, which is $250,000, times, now the rate of change is 25% going down. So this means 1 minus 25% is 0.25 exponent every t years, so exponent t. This becomes $25,000 times 0.75 exponent t. Now the next question is, how much will the machine worth in 10 years? So this becomes y is equal to $250,000 times 0.75 exponent 10. Now evaluating this expression, this becomes 14,078.40 cents. The next question is to find x and y if these two equations are given here. First of all, 16 can be written as 2 exponent 4, so the first equation can be written as 2 exponent 4. Since we have exponent x plus 2y, I'm going to use power to power and multiply the exponent, so it's going to be 4 times x plus 2y. Divided by 8 can be written as 2 exponent 3, so this is 2 exponent 3 times x minus y is equal to 32. 32 is 2 exponent 5. So this equation can be written as 2 exponent 4 times x plus 2y minus 3 times x minus y is equal to 2 exponent 5. Since the bases are the same 2, so I can say that 4 times x plus 2y minus 3 times x minus y is equal to 5. If you simplify this one, we are going to get x plus 11y is equal to 5. This is equation 1. Now I'm going to do the same thing for the second one. 32 can be written as 2 exponent 5, but we have power to power, so it's going to be 2 exponent 5 times x plus 3y over 16 is 2 exponent 4, so I can write it as 2 exponent 4 times x plus 2y is equal to 8. 1 over 8. 1 over 8 is 2 exponent negative 3. This is equal to, since we are dividing two powers with the same base, I'm going to subtract the exponents, so 2 exponent 5 times x plus 3y minus 4 times x plus 2y is equal to 2 exponent negative 3. If we since the exponents, since the bases are the same, so the exponents, they have to be equal, so we're going to get 5 times x plus 3y minus 4 times x plus 2y is negative 3. If you simplify this one, you get x plus 7y is equal to negative 3. This is equation 2. Now we have two equations 1 and 2, and we are going to either use elimination or substitution to solve. Since both of them they have x, I'm going to subtract equation 2 from equation 1, so I get x minus x is 0. 11y minus 7y gives you 4y is equal to 5 minus 3 is going to become 8. So y becomes 8 over 4. So y becomes 2. Now, I can either use equation 1 or 2 to find x. So I'm going to get x. If I use equation 2, I get x plus 7 times y. So 7 times 2 is 14 is equal to negative 3. So from here, I get x is negative 14. If I move it to the right, minus 3. So x is negative 17. The last question is to write two equations to represent the same exponential functions with the y-intercept of 5 and asymptote of 3. We know that the exponential equation is going to be of the form a b exponent x plus c, where there is no transformation on the x, horizontal transformation. So the first information is that the asymptote has to be 3. This means that c has to be 3. So y is equal to ab exponent x plus 3. The next piece of information is that the y-intercept is 5. Y-intercept is when x equal to 0. So 5 has to be equal to ab exponent 0 plus 3. B exponent 0 is 1, so you get a plus 3 is equal to 5. I move 3 to the left. This means that a is equal to 5 minus 3, which is going to be 2. So our equation becomes y is equal to 2b exponent x plus 3. Now, b is the base. B can be anything. Let's assume for this example b is 2. So we get the first form of the equation is 2 times 2 exponent x plus 3. Another form of equation is that remember that this 2 is exponent 1. So I can write this one as 2 exponent x plus 1 plus 3. This is the second form I can write. And you can see that these two forms, they look different, but they are exactly the same functions.